Welcome to Programming for Kids with Scratch 2. I'm Mike Lehman, and thanks for joining me. This series of half-hour shows uses Scratch to introduce computer programming to kids, about 5th grade and up, and curious adults too. You'll learn all about programming in Scratch in this series. It covers loop blocks, repeat, repeat until and forever, decision blocks including if and if else, procedure blocks, variables, lists, messages, events, clones, even microphone and video webcam input. I'll create many programs including games, storytelling, drawing pictures, and programs that demonstrate important programming concepts including objects, threads, and polling. This series is all about doing and shows the creation of all working programs from start to finish. Scratch is a great first programming language and can have children very quickly creating and presenting stories and creating fun animations, all while learning valuable critical thinking skills, problem-solving skills, and the fundamentals of programming without any of the confusing and detailed syntax. Scratch presents programming commands as single blocks that are easily snapped together to make programs with very little typing. Don't let the ease of Scratch fool you into thinking that there's little here. Scratch programs can do a lot of things. Very little math is needed to make fun programs, and I give the very few equations that I'll use in a handful of about 50 challenges. Scratch is free and freely available from the highly regarded university MIT. With your web browser, you can create, share, and save your Scratch programs if you want to. You can also look online at literally millions of shared Scratch programs, and if you like, you can join the Scratch community. You can just sit back and watch this show, or you can go to scratch.mit.edu, click on the Try It Out icon, and have fun learning how to program too. All of these video challenge lessons and more are available at my ProgrammingForKids.info website and at my ProgrammingForKids.info YouTube channel. The countdown timer at the bottom of the screen shows how long until a program is first run. This show number 7 introduces numeric expressions and the mouse down and key press conditional blocks. I'll get started. Data values can be in one of 3 data types: numeric, string, and Boolean, also known as logical data type. This challenge focuses on the numeric data type. Numeric values are real numbers like 0, 3.14, 1 million, -40, and -273.15. I've used numeric expressions in earlier challenges, for example, converting between kilometers and miles. I'll go to Data and create a couple variables. I'll create miles, and I'll create kilometers, which I'll abbreviate as km. Kilometers is equal to miles times 1.6. I'll also want to set miles. I'll select miles, make that 1. For the expression for kilometers, I'll need miles. I'll go to Operators, multiply, miles times 1.6. I'll get the green flag event handler, and the program will be ready to run. I'll move miles and kilometer into the center. Click on the green flag. When miles is 1, kilometers is 1.6. That's good. I'll try another value. I'll try miles of 5. Run it. I get kilometers as 8. So it's acting correctly. I can convert from kilometers to miles. I'll duplicate this code. I'll start with kilometers. I'll set kilometers to 1.6. I want to set miles. I'll change miles to kilometers, and I'll change multiply to divide. Miles is equal to kilometers divided by 1.6. I'll run it. For 1.6 kilometers, I get 1 mile. I'll change 1.6 kilometers to 8. Run it. I get 5 miles. Numeric expressions can be combined, like when converting between Fahrenheit and Celsius. I'll clean this up a little bit and reuse some of it. I'll go to Data, get kilometers and miles off the stage, and I'll create another variable. I'll create Fahrenheit, and I'll create Celsius. Celsius is equal to the quantity of Fahrenheit minus 32 divided by 1.8. To convert from Fahrenheit to Celsius, I first have to subtract 32 from Fahrenheit. I'll get Fahrenheit and operators. Fahrenheit minus 32, and divide that by 1.8. Change the 6 to an 8. Move it into the second set. I'll change the first one to Fahrenheit, the second one to Celsius. I'll clean that up. I'll set Fahrenheit to 32. Move Fahrenheit and Celsius into the middle. I'll run the program. Fahrenheit of 32 is Celsius 0. 32 degrees Fahrenheit is 0 degrees Celsius. I'll change Fahrenheit to 212, which is the boiling point for water. Run it. I get Celsius of 100 degrees. One more value, I'll try Fahrenheit at minus 40. Minus 40 degrees is the same for Celsius and Fahrenheit. I'll run it. And I have negative 40 for both Celsius and Fahrenheit. I can also convert from Celsius to Fahrenheit. I'll reuse this code, copy it, move that out of the way a little bit. I'll set Celsius to 0. I want to set Fahrenheit. I'll break this out. I want to multiply Celsius, right-click, change it to Celsius. Right-click on the division, change it to multiply. I want to multiply Celsius by 1.8. Then I want to add 32 degrees. I'll change the minus to plus. Now I'll run the program. 0 degrees Celsius gives me 32 degrees Fahrenheit. I'll change Celsius to 100, boiling point, and I'll run it. I get 212 degrees Fahrenheit. I'll change Celsius one last time to negative 40 degrees. Run it. I get negative 40 degrees for Fahrenheit. I can compute the circumference and the area of a circle given its radius. I'll go to Data, Celsius and Fahrenheit, get rid of the extra set of commands, and I'll create some variables. I'll create pi. I'll create the radius variable. I'll create area. And I'll create circumference. I'll move them into the middle of the stage. And I'll break this command off. Change Celsius to pi. And the value is 3.14159. I also want to set the radius. I'll duplicate. Pull down radius. I'll set radius to 1 for the first test. Then I want to set the circumference. Break this off. I'll get rid of the addition. Duplicate. Circumference is equal to 2 times pi times the radius. Drop that in. Circumference is equal to 2 times pi times the radius. I'll attach it. I'll reuse this set to make the area. Area is equal to pi times radius squared. Area is equal to pi times radius. Program's ready to run. I'll click on the green flag. With a radius of 1, I get twice pi for the circumference, and the area is pi. That looks correct. I'll change radius to 10, so the number should be 10 times larger. Click on the green flag. Radius is 10, circumference is 62, and area is larger at 314. The values look correct. Scientific notation is available for those who understand it. I'll show it briefly, But don't worry if you don't understand it. It's not necessary to using Scratch. It's a convenience. The speed of light in a vacuum, known as c, is approximately 186,000 miles per second, for 3 digits of accuracy. In scientific notation, 186,000 is 1.86 times 10 to the 5th. If you multiply 1.86 by 10 5 times, 2, 3, 4, 5, you get 186,000. To set a variable to 186,000 using scientific notation in Scratch, you can assign the variable the value 1.86e5, where e refers to the exponent for the base 10, and 5 is the number of that exponent. For example, initializing c to 1.86e5 is the same as initializing it with 186,000. I'll go back to the program and try it. I'll create the variable c for the speed of light, and I'll set it to 1.86e 10 to the power of 5 e5. I'll get the equals operator, and I'll compare c to 186,000. Go to Data, get c. I'll start the program. Not that this is attached to it. I'll click on Set. C is now 1.86e5. When I click on the equals expression, I get true. For my next example, I want to randomly select backdrops for the stage 8 times. I'll get rid of these variables off of the stage, and I'll clean up all the commands. I'll get a couple new backdrops. Go to New Backdrop, scroll down, select Stage 1, get another backdrop, scroll down, select Stage 2, I'll go to Scripts. The scripts are gone. The scripts are gone because I have the Stages scripts. I want the cat's scripts. Click on the cat sprite. I can see that the cat scripts still exist, but for this example, I'll use the Stages scripts area. I'll bring the cat down onto the stage and reselect the Stages scripts. To switch backdrops, I'll go to Looks. There are fewer looks commands for the stage, but that's understandable since it's not a sprite. I'll select Switch Backdrop and wait. Switch Backdrop will change the backdrop on the stage. I can select the different backdrop names. I can also select them by number. If I go back to backdrops, I see that each of the backdrops has its own number, 1, 2, 3. I'll go back to Scripts. I'll choose Operators. I want the program to randomly pick a backdrop. I'll use Pick Random. I only have 3 backdrops, so I'll change the 10 to a 3. Pick Random will generate a random integer between 1 and 3, so it'll generate 1, 2, or 3. I'll click on it a few times. 1, 2, 1, 2, and there's 3. I'll drop it in the Switch Backdrop, go to Control, get a repeat loop, change the 10 to an 8, Events, green flag is clicked. Go back to Control and add a wait so this doesn't go too fast. The wait here is only making sure that the backdrop is visible. It's not waiting for a specific time like the wait command. Program's ready to run. When I click on the green flag for 8 times, it will switch the backdrop to a randomly selected backdrop, which may be the same backdrop that was currently being displayed, and wait for a second. So I'll click on the green flag and the program will run in 8 seconds. There's 1, 2, 3, 4, 5, 6, 7, 8. This example's working. I'll go back to Operators and look at some more numeric operators. I'll use the round operator. I'll click on Block Help to get some more information about round. Round gives the value of the integer closest to the number. Scratch has a couple examples here. Round of 5.1 is 5. Round of 5.6 is 6. I'll get rid of the help Try a couple different values. Try 4.4. Round of 4.4 is 4. Round of 4.5 is 5. And round of 4.6 is also 5. Finished with round. I'll get the function operator. The function operator has a list of functions that are available. Many of these functions are related to higher mathematics, including trigonometry, so I won't talk about them here. But I will look at 3 of these. Absolute. Absolute returns the magnitude of the number. If the number is negative, it returns the positive value. For a few quick examples, absolute value of 9 is 9. Absolute value of 0 is 0. Absolute value of -1 is positive 1. Sometimes an integer value is needed for a real number, a number with a fractional part like 1.3 or -2.4. Scratch has 2 functions to make integer values from real numbers, floor and ceiling. Floor returns the closest smaller integer value for a number. The integer is to the left on the number line. Ceiling returns the closest larger integer value for a number. The integer is to the right on the number line. I'll show this on a number line. Various numbers can be found on the number line. 2.7, 1.3, 1, -2.4. For the number 2.7, the floor of 2.7 is 2. 2 is the closest smaller integer value. The ceiling for 2.7 is 3. 3 is the closest integer value larger than 2.7. The floor value for 1.3 is 1. 1 is the closest integer value less than 1.3. The ceiling for 1.3 is 2. 2 is the closest integer value larger than 1.3. The floor and ceiling values for 1 are 1. 1 is already an integer value. The ceiling for -2.4 is -2. -2 is the closest integer value greater than -2.4. The floor for -2.4 is -3. -3 is the closest integer value less than -2.4. I'll go back to the program now and show these values. The floor of 2.7 is 2. The ceiling of 2.7 is 3. The ceiling of 1.3 is 2. The floor of 1.3 is 1. The floor of 1 is 1. The ceiling of 1 is 1. The ceiling of -2.4 is -2. The floor of -2.4 is -3. Scratch has various trigonometric and algebraic functions available. I'll use some of them in an advanced challenge later on for those familiar with them to show how easy they are to use and how powerful they are. I'll discuss the mod operator in a future challenge. It needs its own challenge. I'm finished with this example and this challenge now. I want to encourage you to use the examples and get experience using numeric expressions. Play with the different operators you've just seen. Try creating more formulas like converting feet to inches or miles to feet or yards. Try changing the program that randomly selects backdrops to randomly display more backdrops. Or for a harder challenge, try changing that same program to not use the last used backdrop, so the backdrop will appear to always change on the stage each second. But above all, have fun with the challenge. In this challenge, I'll show some examples of using the mouse down and key press conditional blocks. I'll go to Sensing, Mouse Down, Key Pressed. I can look at help for these blocks. Help block, mouse down. Mouse down has the true value if the mouse button is pressed. I'll look at help for the key pressed. Key pressed has the true value if the key is pressed down. I'll close help. For this example, I want the cat to display down if the mouse button is down, or up if the mouse button is up. I'll need a loop, Control, Forever, and an if-else. Put the if-else in the loop. If the mouse is down, I want the cat to say down. Looks, say, change that to down, copy it, else, I want the cat to say up. And do all of this when the green flag is clicked. Now when the green flag is clicked, the script will loop checking to see if the mouse is down. If it's down, the cat will say down, otherwise the cat will say up. I'll run it now. Click on the green flag. The mouse is up. Press down and up, down, up, down, up, and several times real quickly. It's working nicely. I'll stop it. I'm finished with this example. I'll save the if. For my next example, I want the cat to move towards the mouse pointer when the mouse button is down. First, I'll need to move the cat towards the mouse pointer. Go to Motion, Point Towards, Mouse Pointer. Now it'll point towards the mouse pointer while it moves. I'll change 10 to a 5 while it moves 5 steps. Now when the green flag's clicked, the cat will loop pointing at the mouse pointer and moving 5 steps. It's ready to run. Start it. There it comes. I'll stop it. I'll change it so the cat sprite will move towards the mouse pointer only when the mouse button is pressed. Go to Control, If, and copy mouse down, duplicate. Now when the green flag's clicked, it'll loop checking to see whether the mouse is down. If the mouse is down, it'll point towards the mouse pointer and move 5 steps. I'll move this out of the way. I want the cat to start in the middle of the stage. I'll go to Motion, get Go To. Middle of the stage is at 0, 0. I'll change those XY positions. I'll run it, click on it. Cat's in the center now. I'll add the Go To into the blocks. I also want the cat to be pointing to the right when it starts. I'll get point and direction. Already pointing to the right at 90. That's good. I'll run it. Now the cat's pointing to the right. I'll add this to the code. Now when the green flag is clicked, the cat will start in the middle pointing to the right, continually looping to see when the mouse is down. When the mouse is down, the cat will move towards the pointer by 5 steps. I'll run it now. The cat will move only when the mouse button is down. I'll click a few times. There comes the cat. This is working. I'll stop it. I'm finished with this example. For my next example, I want the cat sprite to change color when the space key is pressed. I'll get rid of the loop here. Insert in my next example to change the cat's color. Control, Forever, get an if. When the space key is pressed, this will be true, and it'll be false if the space key isn't pressed. I'll try some examples. No space key is false. Space key down, true. No space key, false. If the space key is pressed, I want to change the cat's color. Change color effect. Smaller change, instead of 25, make it 2. Change color effect changes the sprite's color. Now when the green flag is clicked, the cat will be positioned in the center pointing to the right. It'll loop checking to see if the space key is pressed, and when it is, the cat's color will change a little bit. The loop will go quite fast, so the color will change pretty quickly. I'll try the program now. Press the space key some. Down, up, down, up. That's working nicely. I'll stop it. I'm finished with this example. For my next example, I want the cat sprite to draw a line on the stage, but draw only when the space key is pressed. I'll get the forever loop out of the way. Control, Forever. I want the cat to move. Move. I want it to move more. I'll try 20. Now to draw a line, I'll go to Pen, Pen down, Pen up, and Clear. Pen down will draw the sprite's path as the sprite moves around the stage. Pen up will not draw the sprite's path as the sprite moves around the stage. And Clear removes pen marks and stamps from the stage. It's nice for starting a new drawing. I want the pen up or the pen down before the move. I'll go to Control, If Else. I'll move after the if. Copy key pressed, duplicate. If the key is pressed, I want the pen down to draw on the stage, else Don't draw on the stage with pen up. When the green flag's clicked, the cat will move to the center pointing to the right, and the cat will loop always moving. If the space key is pressed, it'll write on the stage, otherwise it won't. I'll run it. Oh, the cat hit the edge of the stage. I'll stop it. I need the cat to bounce off the edge of the stage. I'll go to Motion. If on edge bounce, it'll check right after the move. Now when the green flag is clicked, it'll draw on the stage if the key is down, always moving, and if the sprite's on the edge of the stage, it'll bounce off. I'll run it now. Cat's bouncing off the edge. Hold the space bar down, but it's drawing on itself. That's not good. I'll stop it. To draw something different, I have to have the cat pointing in a different direction. I'll change 90 to 30. Now when the green flag's clicked, the cat will start pointing in a different direction. I'll try it again. Click on the green flag. It's moving around, but it didn't erase the first drawing. I'll stop it. Needs to clear the stage for a new drawing. I'll add clear into the handler. Now the pen marks and any stamp marks are cleared from the stage. I'll run this. Press spacebar up and down. Hold it down, it'll keep drawing. I'll stop it. I'm finished with this challenge. I encourage you to play with the examples and get experience with mouse down and key pressed. Try changing the examples. Try changing the number of steps to get a different design. Try changing this example to still draw, but only draw when the space key is pressed. Is pen up needed anymore? Try changing the pen color while the cat moves by adding the Change Pen Color block. For a bigger challenge, try changing this first example so that if the mouse is down, or if the key is pressed, the cat will say down, otherwise say up. You'll want to play with operators, the OR condition, but above all, have fun with the examples. I'm glad you could join me. You can review these and all of my challenges at my programmingforkids.info website and on my programmingforkids.info YouTube channel. I encourage you to try the things you've just learned and explore the extra challenges I've suggested. I hope you can join me for the other shows. Until next time, have fun being creative.